Hello class, this is chapter 1-4, measuring in metric units. One of the nice things about the metric system is that it is all based on 10. So we often use our shortcut of multiplying by powers of 10 and dividing by powers of 10 in order to do conversions and work with our metric system. In the metric system, we have three different categories of measurements. The first one is length. The millimeters, which are as thick as a dime, if you can visualize that. The centimeter, which is actually as wide as most people's little finger, unless you're a rather petite person. The meter, which actually measures from the doorknob to the floor on most standard doors. And the kilometer, which is actually quite long. It's 11 football fields, if you can imagine that. It is, however, shorter than a mile. It's a little more than 2/3 of a mile. In capacity, we have the milliliter. If you can think about the eyedroppers that we use in science, that holds a milliliter. A liter, however, is quite a bit bigger. It actually holds, it's about like a quart. It's just a little bit bigger than a quart. When we talk about mass in science, math, however, usually refers to it as weight. And the distinction between mass and weight in math is not quite as definite as it is in science. So we use them interchangeably in a math class. The milligram is really small. That would be like a mosquito landing on your arm. A gram is about the mass of a paper clip. It's also about 3 raisins, if you can think of that. A kilogram is quite a bit bigger. That is a mass of a bunch of bananas or a pair of men's shoes. It's actually 2.2 pounds, if you want to think of it in terms of pounds. So it's like a couple of loaves of bread. One of the things they will ask you to do is choose which metric unit you should use. If we are going to be looking at the mass of a bicycle and measuring the mass, think about what we want to measure it in. Now, if you go to your weights and mass, do you really want to compare it to how many mosquitoes would be a bicycle? Or how many paper clips would be a bicycle? Or are we talking about the bigger unit of kilogram? And yes, we would use the kilogram to measure the mass or the weight of a bicycle. What about the capacity of a sink? Well, let's look at our capacities. Would you really like to measure how much a sink holds by using an eyedropper for a milliliter? I don't think so. We would probably prefer to use the liter, which is at least a little bigger than a quart. Notice that the abbreviation for a liter is a capital L, printed L. The capacity of a test tube. All right, we've worked with test tubes in science. Think about it. Are you going to measure it according to a liter, like a quart, 2 pop bottles, or half of one of those big 2-liter bottles? Or are you going to measure capacity of the test tube closer to eyedroppers? Probably with the eyedroppers, and we would go with milliliters. The thickness of a wire, a piece of wire. Let's look at our length. Is it going to make sense to go with a dime and compare it to a dime? Or compare it to your little finger, how thick a wire is? Or from the doorknob to the floor? Or 11 football fields, 2/3 of a mile? Yes, we're going to want to use millimeters for the thickness of a wire. One of the other activities or assignment parts that they're going to ask you to do is choosing a reasonable estimate. We're going to talk about the height of a classroom from the floor to the ceiling. Okay, 3 centimeters. 3 little fingers, is that how tall a room is? 3 meters, which is from the doorknob to the floor, which is roughly about 9 feet because a meter is a little more than 3 feet. Or do we want to go with 33 football fields? Well, that's not going to make sense either. So the middle one, 3 meters, makes a lot more sense. Let's try capacity. What do you think? Milliliters? That's kind of like eyedroppers. or 180 liters. That's like 2 regular pop bottles these days. Or if you want to go with kiloliters, which is 1,000, 1 kiloliter is 1,000 quarts. So we're going to be going with that one. No, that's the one that a lot of people choose, but remember, it would be 180 quarts. That's well over 40 gallons. So you're going to want to go with 180 milliliters. Let's look at the mass of a bag of flour. A bag of flour, 2.3 milligrams. That would be 2.3 mosquitoes. That doesn't make sense. 2.3 paper clips? No, that doesn't make sense either. So the kilogram would make far more sense. What about the length of your shoe? 28 dimes? Now remember, that's the thickness, not the diameter, the thickness. If you had a stack of 28 dimes, would that stack be as high as your shoe? No, it would not. What about 28 centimeters? That's a possibility. But what about 28 meters? Now remember, a meter is about 3 feet. So 28 times 3 is going to be way up there. That's a pretty big foot. So we're going to go with 28 centimeters. Lastly, we are going to talk about changing metric units. You might recall using these scales in math classes in the past, that from the left to the right it goes kilometers, hectometers, decameters, meters, decimeters, centimeters, millimeters. Now it's the same basic prefix, the K, the H, the DA, and just the plain unit, then the D, the C, and the M. We just interchange what unit we're talking about. So it's kiloliters, hectoliters, decaliters, liters, deciliters, centiliters, milliliters, kilograms, hectograms, decagrams, gram, decigrams, centigrams, milligrams. The first thing we're going to do is check to see which direction we're going to want to move. We're going to convert from centimeters to meters. We're going to go from centimeters to meters. That means we're going to move left. Now, how many places are we going to go? 1, 2. So we're going to move 2 places left. Here's our decimal point. 1, 2. Our answer is going to be 4.59. The next time, we're going to go with kilometers. We switch colors here. We're going to go from kilometers to meters. Well, this time we're moving to the right. How many places are we moving? 1, 2, 3. So we're moving 3 places right. 1, 2, 3. Now if you'll notice, underneath these little dips, there are no decimals. So that's where I need to put in a 0. So it's going to be 900. Now the same basic thing works if we're working with milliliters or with grams. This time we're going from milliliters to liters. If you'll notice on the scale, which direction are you going? Left. How many places are you moving? 3. So that decimal point is here. We're going to move it 3 places to the left. That's 0.789. In D, we are going to go from grams to kilograms. And again, we're going to be moving to our left, and we're going to be moving 3 places. So our answer is going to be 0.324. What do we do, however, when we have combinations? Here I have 5 kilograms and I have 32 grams. I want to change everything to kilograms. So our main problem is changing 32 grams to how many kilograms. Now if you look back at your scale, you'll note that you're going from grams to kilograms, which means you're moving left, and you're moving 3 places. So that means you're going to have 0.032. This 5 is already there, so we just add it. We're going to add 5 plus 0.032. We're going to get 5.032 kilograms. If we look at F, what unit do we want? We want milliliters. We, however, have our 2 liters. So we need to change liters to milliliters. 2 liters will equal how many milliliters? If you look on your scale, you're going from liters to milliliters, which means you're moving to the right, and you're moving 3 places. So we're going to have 2,000 milliliters. But the problem also contains 198 milliliters. So our complete answer is 2,198 milliliters. In G, we're going to have a story problem where we know that there's a beaker that holds 150 milliliters, and I have a bigger container that holds 2 liters. How many beakers can I actually fill? Okay, just be filled. Notice that my one measurement is in liters. Now here, I have a choice to make. Do I want to change the beaker measurement to liters and then divide? Or do I want to take the liters to milliliters and then divide? I like to avoid decimals. And if I'm going to change milliliters to liters, I'm going to end up with decimals. So I'm going to change my 2 liters to 2,000 milliliters. Then I can divide by my 150. Oops, there. And that will go 3 times, which is 450, and I have 50 milliliters left over. Now they're really only asking me for what I can fill, so I'm going to stop there and just write 13 beakers. And that concludes lesson 1-4. Catch you next time.